Welcome, ladies and gentlemen. So what I'd like to do is just kind of go through a summary of what you're supposed to learn in this course in regards to graphing absolute value inequalities. So as part of my summary, what I'd like to do is just kind of go through the overview of graphing absolute value inequalities and then kind of highlight some tips and tricks and some common mistakes that you will find as you work through this course, or work through problems on your own. So the basic summary for graphing absolute value inequalities is basically what we're going to do is graph absolute value equations first. We can kind of ignore the inequality symbol at first and just graph the equation. So to do that, we want to be able to identify the transformations and identify the new vertex. To identify where my vertex can be shifting left or right, up or down, and also to identify if there's going to be a reflection or if there's going to be a compression or a stretch. So we identify where the new vertex is based on the transformations that we have, and then we either graph the parent graph from there, or if there is a compression or a stretch, meaning the values for A and B in your transformation equation, then what we can use is use a table of values. And the way I like to use it is use a table of values, choose points that are either to the left or to the right of your vertex, which lies on the axis symmetry, evaluate with the table of values, plot those points, and then reflect those points over the axis symmetry. The next thing we need to do now is determine, all right, so once we have a graph, is that graph a part of the solution or not? If it's a part of the solution, if we have it assigned that is greater than or equal to or less than or equal to, and it's not a part of the solution if it's greater than or less than in your inequality problem. So when it's a part of the solution, we just graph it as a solid line, just like an equation. When it's not a part of the solution, that means we're going to represent the graph as a dashed line. The last thing we need to do is determine the test point, or determine what the points below or above are going to be a part of our solution. So to do that, we choose a test point. The best test point to use is 0, 0, unless your graph lies on 0, 0. Therefore, you'd have to choose another point, maybe 1, 1, or 0, 1, or 1, 0, and then plug in those x and y coordinates of your test point into your inequality. And if that makes the inequality true, then all the points where that test point are, like say if the test point lies below the graph, that means all the points below the graph are going to be true, so we'd shade them. If it is false, that means all the points above the graph are going to be true, so we'd shade above the graph. And that works the same if your test point was above your graph, and if it was true, that means all the points above are true, so you'd shade, and if it was false, then you'd shade all the points down below. So now let's go and get to some tips and tricks. One of the biggest things that I see as far as mistakes with students, or things that I think are helpful, is to write down. If you know you're going to be shifting right, or you know there's going to be a reflection over the x-axis, write it down. It takes a little bit more time, I know, but this is the best way to ensure that you're not going to forget, and you can always go back and check your work and make sure that you are doing exactly what you thought you were going to do. The next thing is using the parent graph and the axis of symmetry. I see so many students use a table of values and they don't use the axis of symmetry, and they'll graph a whole table of values and it's just a straight line. But they never thought to identify where's the vertex, choose points to the left, and then reflect over the axis of symmetry. The other thing is I see a lot of students not using the parent graph or using a table of values when there is no transformation, there is no compression or stretching. If there's no compression or stretching, you literally have your parent graph just shifted left, right, up, down, or reflected. So you can just take that graph, because remember the slope for the parent graph is up 1 over 1, up 1 over 1, up 1 over 1, that nice V. You can just plant that onto your graph based on whatever transformations you have. The last thing is the test 0, 0. I say it's a tip and a trick. It's just the way that I teach it. You can use any point in the world, but it's very helpful to use 0, 0. Just as far as algebraically, it's a lot less work. So some common mistakes. Well, the first thing is understanding the wrong transformations. And that one comes from my trick of saying writing them down. Students forget them. But I think even bigger than that is students always mix up x minus h and say, oh, that's going to be shifting to the left. Well, remember, that is your transformation. So if I had absolute value of x minus 3, that means h is equal to a positive 3, meaning I'm going to shift to the right. If I have x plus 3, that means really the same way to represent that is absolute value of x minus negative 3. So that means if I have my h is negative 3. Therefore, I'm going to shift to the left. So you can kind of always think about when it's inside the function, you're just kind of doing the opposite. If it's negative, you actually go to the right. If it's positive, you actually go to the left. And the next thing is doing the wrong shading. This comes from test point 0, 0, but it also comes from just students, using a test point, seeing it's true, and then, shading the other way. or just getting that mixed up as they're doing that, or choosing another point that's on the line and not knowing that you have to pick a point off of the graph when you're doing your shading. So there you go, ladies and gentlemen. That is just kind of a basic summary for graphing absolute value inequalities. Thanks.